If u is equal to tan inverse of x cube plus y cube by x plus y, prove that x square into del square u by del x square plus 2xy into del square u by del x del y plus y square into del square u by del y square value, which is equal to 2 cos 3u into sin u. Second, we have to prove that x square into del square u by del x square plus 2xy into del square u by del x del y plus y square into del square u by del y square, which is equal to 1 minus 4 into sin square u into sin 2u. This is another type of problem. Consider the given problem, that is u is equal to tan inverse of x cube plus y cube by x plus y. As before, we have to consider this value as z, which is equal to, if we take tan inverse to the left hand side, that is tan u, which is equal to x cube plus y cube by x plus y. First step, we have to reduce this to homogeneous function form. We already know to reduce to homogeneous function form, we have to take the common factor as this, that is, if we take x cube as common in numerator and x as common in denominator, we get as x cube into 1 plus here y by x whole cube by x into 1 plus y by x. Here x cube x gets cancelled, the remaining is x square into, here this is of the form f of y by x. So we can conclude that this is a homogeneous function of degree 2. Hence we get n value as 2. So we get from Euler's theorem, we get the value as x into del z by del x plus y into del z by del y, which is equal to n into z. Substituting z value as tan u, we get as x into del of tan u by del x plus y into del of tan u by del y, which is equal to, here n value is 2 into z value is tan u. Here differentiation of tan u with respect to x is secant square u, hence we get x into secant square u into, again differentiation of u with respect to x is del u by del x plus y into differentiation of tan u is secant square u into differentiation of u with respect to y is del u by del y, which is equal to 2 into tan u as it is. Next step, we have to take secant square u outside the bracket, we get as secant square u into x into del u by del x plus y into del u by del y, which is equal to 2 into tan u. Take secant square u to the right hand side, that becomes x into del u by del x plus y into del u by del y, which is equal to 2 into tan u divided by secant square u. We know that tan u we can write it as sin u by cos u, and 1 by secant square u is cos square u. That is x into del u by del x plus y into del u by del y, which is equal to 2 into, here tan u is sin u by cos u into, here 1 by secant square u, that is reciprocal of secant square u is cos square u, hence we get cos square u. Here cos u gets cancelled. The remaining is here 2 into sin u into cos u. This is of the form, that is sin 2x is 2 sin x into cos x. So we can write it as sin 2u, that is x into del u by del x plus y into del u by del y, which is equal to sin 2u. Here we have to observe that this problem is of the form, we already discussed the second proof, that is x square into del square u by del x square plus 2xy into del square u by del y into del x plus y square into del square u by del y square, which is equal to n into n minus 1 into u. We can solve this problem using two methods. First method is, after finding x into del u by del x plus y into del u by del y, which is equal to, that is sin 2u. Next step, as we derive this equation, next step, if we differentiate this equation partially with respect to x and y and multiply x and y inside the bracket and simplify, we get the value. Or we can apply another formula, that is, we have to remember this formula, that is homogeneous equation of degree n is given by the formula x square into del square u by del x square plus 2xy into del square u by del y into del x plus y square into del square u by del y square, which is equal to g of u into g dash of u minus 1. We have to remember this formula. Now I will use this method to solve this problem. Here after obtaining x into del u by del x plus y into del u by del y, which is equal to some value, that is sin 2u, call this value as g of u. Next, to find the value, that is, we have to show that first one is x square into del square u by del x square plus 2xy into del square u by del y into del x plus y square into del square u by del y square value we have to prove. So consider this formula and simplify, we get as x square into del square u by del x square plus 2xy into del square u by del y into del x plus y square into del square u by del y square, which is equal to, here substituting this value as g of u into g dash of u minus 1. Here g of u is sin 2u into g dash of u is, you have to differentiate this sin 2u with respect to u, we get as 2 into cos 2u minus 1 as it is. Next step, multiply sin 2u inside the bracket, we get as 2 into sin 2u into cos 2u minus sin 2u into 1 is sin 2u. We know that 2 sin 2u into cos 2u, this is of the form sine 2x, that is sine 2x is 2 sin x cos x. Here in the place of x we have 2u, hence we get the value as sine 4u minus sine 2u as it is. Here sine 4u minus sine 2u, this is of the form sine c minus sine d. We know that sine c minus sine d, we can write it as 2 cos of c plus d by 2 into sine of c minus d by 2. Here c is 4u and d is 2u. Substituting these values here we get as x square into del square u by del x square plus 2xy into del square u by del y into del x plus y square into del square u by del y square value as, here substituting c value as 4u and d value as 2u, we get as 2 cos of 4u plus 2u by 2 is 4u plus 2u is 6u by 2, hence we get as 2 cos 3u into sine of 4u minus 2u by 2, that is 4u minus 2 is 2u by 2 is u itself, hence we get the value as 2 cos 3u into sine u. We have shown that x square into del square u by del x square plus 2xy into del square u by del y into del x plus y square into del square u by del y square value, which is equal to 2 cos 3u into sine u. In the similar way, we have to prove second one, that is x square into del square u by del x square plus 2xy into del square u by del y del x plus y square into del square u by del y square, which is equal to, here g of u is sine 2u into g dash of u is 2 cos 2u minus 1. Now we know that from trigonometric formula, cos 2x in terms of sine, we can write it as 1 minus 2 sine square x. That is cos 2x is equal to 1 minus 2 sine square x. Here in the place of x we have u. Substituting the value cos 2x here we get as sine 2u into 2 into, in the place of cos 2u we can substitute as 1 minus 2 sine square u minus 1. Here multiplying 2 inside the bracket and simplify we get as sine 2u into 2 into 1 is 2 minus 2 into 2 is 4 sine square u minus 1. Here 2 minus 1 is 1. Hence we get x square into del square u by del x square plus 2xy into del square u by del y into del x plus y square into del square u by del y square, which is equal to sine 2u into the 2 minus 1 is 1 minus 4 sine square u. This completes the problem.